So a binary operation star on a set S with members A, B, C, D, E is defined by the entries in the table below. What's the identity element of the set under the operation star? So to go about getting the identity element of the set under the operation star, we need to therefore know that whatever identity will mean a number as in is x multiplied by either multiplied or added to x, either multiplied by x or added to x, and that identity is e. That will still give us x. So here, what we're going to do is that we're going to see if any of these letters is an identity. And how do we know if a letter is an identity? A letter here with identity if a row multiplies a column or a column multiplies a row, and then we get the same row that multiplies the column. For instance, if B, which is the row, multiplies E, if we get A as a result, that means that whatever we have here is the identity. Okay, so let's proceed. So let's try the first. Let's use the column against the row. So from the first column, from our first column, and just that's just an illustration. So from first column, so okay, let's just try. Okay, for identity elements, let's say x that should be x. So that would be our guide. For first column, a star e is equal to e. A star e is equal to e. So meaning that a is not identity element. So a star e is not equal to e. So if it was a star a was equal to e, that means that a here is an identity element. So since a star is not equal to e, and this is not an identity element. This is not an identity element. I can say a is not an e, which is a here is not an identity element. So let's move to the second one. So e star b is equal to e. Let's go to the second a star b. That's what that will give us, a star b. So from second column, a star is a star b. A star b is equal to c. I don't mean a star b is equal to e. I mean that b is an identity element, but a star b is equal to c. So b is not an identity element. B is not an identity element. So let's go to the third row. So from third column, so a star c is equal to e. A star c is equal to e. So this meets our definition of identity element, where we say x star e will give us x. So that a combined, when a is combined to c, we got a back. So we say a is an identity element. A is an identity element. Okay, so that's the proof. You can also see that. So continue with our investigation to be sure that our identity element is in this column, or in this C column. You can see that a star c gives us a, b star c gives us b, c star c gives us c, d star c, and e star e. So for further proof shows that a star b star c is equal to b, C star C, C star C is equal to C, C star C is equal to C, D star C, D star C is equal to D, E star C is equal to E. You see that each of them, whenever B multiplies or B is combined to C, you get B back. When C is combined to C, you got C back. When D is combined to C, you get D back. And when E is combined to C, you get E back. So you see that C in this case is C is the identity element. So this shows how we get an identity element using tabular binary operation for identity elements. Using tables to determine identity elements. The identity elements with respect to the multiplication shown in the table above is, we proceed by saying for identity elements, we want either x star e will give us x, or we say e star x will give us x. We have these two variations because when it comes to table, you can either go by row against column or column against row. Either way, if you go by row against column, like say P operation P, that's this value here, R, or P operation P, which is column against row, is still R. So if you choose to go, whether you choose to use start with the column against row or row against column, for as long as it's identity element, it should X operation E should give you X, or E operation X should give you X. So that's the rule. Now let's start with column or rows. Let's use column. So from first column P operation P operation P is equal to R. P operation P is equal to R. Didn't give us P back, so that means that P is not an identity. It's not an identity element. So let's go to the second row. From second column is this column P operation Q. Give us P operation P operation Q. So here this operation is this operation. So P operation Q is equal to what? P. So this is exactly what we have here for identity. So X, which is the first element, combined to identity element gives you X back. So P operation Q gives us P. Therefore Q is an identity element. Now we don't need to try the other rows or columns anymore. Rather, what we need to do is to check if this trend is continuous. We are going to use Q operation Q to see we're going to get Q back, R operation R. So if we get it back, that will verify that Q indeed is an identity element. So let's check for further proof. So this will give us, so when we use Q operation Q, let's see what it will give us. Q operation Q, Q operation Q. What is it giving us? Q. Okay. R operation Q. What is it giving us? R operation Q. What is it giving us? R. That's okay. S operation Q. What is it giving us? S operation Q. What is it giving us? S. So all of these indicate that this shows that This shows that Q is Q is the identity. Q is the identity element. So the option here is B. B. The answer is Q. The table above defines a binary operation on 1, 2, 3. Find its identity element. So for identity see X operation E should give us what? X. So let's see what the operation here will give us. So it's taking first row, taking first column, taking first column. This is row and it's 1 plus 1. 1 operation 1, but I'm taking column, so 1 operation 1. 1 operation 1 is 2. Taking first column, 1 operation 1 is 2. 1 is not an identity because it didn't give us 1 back. 1 is not an identity. 1 is not an identity element. So 2 plus 1 gives us 3. 2 plus 1, 2 operation 1 rather is 3. 2 operation 1 is 3. Therefore, if it's an identity element, it would have given us 2 back, but because it didn't give us 2 as the 2 we have here, that shows that 1 is not an identity element. 1 is not. 1 is not. Oh, sorry. Okay. 1 operation 2 or 2 operation 1 is 6. 1 operation 2 or 2 operation 1 is 3. 1 operation 2 is 3. So it's the same thing. So 1 is not. And 1 is not identity element. And then the last one, 3 operation 1 is 1, or 1 operation 3 is 1. 1 operation 3 is 1. 1 operation 2 is 1. Or 3 operation 1 is 1. So in that way, you see that when 1 combines to 3, we got 1 back. So 3 which combines to 1 to give us 1 back. 3 is an identity element. So for further check, let's check. 3 is an identity element. So 1 operation 3 is 1, 2 operation 3 is 2, 3 operation 3 is 3. You can see that 2 operation 1 operation 2 is 1, and 2 operation 2 is 2, 3 operation 2 is 3. And what do we say? Look at what you're having here. And look at this. X operation is X. 1 operation 2 is 1, 2 operation 2 is 2, 3 operation 2 is 3. So what does this tell you? It tells you that it implies that 3 is the identity element. In the table above, P operation K is defined as what remains of the sum of P and K when divided by 6. What is the identity element? For identity to hold, so if let's say x can be any number here, x operation E should be x, or E operation x should be x. So let's taking the first row, taking the first row, So 0 operation is 0. 0 operation 0 is equal to what? Is equal to 0. Since 0 operation 0 is equal to 0, that means 0 is an identity element. 0 is an identity element. Let's still see. So 0 operation 1 give us 1. So now because we are using row against column, so it will be in this form, identity element plus operation x will give us x. So there's 0, which is the row, is the identity element. So 0 operation 1, 0 operation 1 to give us 1. So what we have is what we have here. So 0 operation 1 is equal to 1. So which means there is identity element in that confirmation. So 0 is an identity element. Let's run our confirmation test here. Confirmation, further confirmation test. So let's see. 0 operation 2 gives us 2. 0 operation 2 equal to 2. 0 operation 2, what is giving us? 0 operation 2 is 3. 0 operation 4 is giving us 4. 0 operation 5, what is giving us? 5. So this implies that this implies that 0 is the identity. 0 is the identity element.